In the previous lesson, we saw the implementation of binary search in its basic form. We solved a problem in which if we have a sorted array of integers, something like this, and if we want to find out whether a number exists in this array or not, so let's say we want to find out whether number 10 exists in this array or not, then our algorithm returns us that 10 exists at index 3. And if we want to search for a number that does not exist in the array, then our algorithm returns us that the number that you are looking for does not exist in the array. So if we want to search for 11 in this array, then our algorithm says that 11 does not exist in the array. Okay, so now I will modify this array. Now this array is still sorted, but the only difference is that we have 3 occurrences of number 10 in the array. Now let's say we want to search for the number 10 using binary search. Then what will be the index of 10 that we return? We could return 2 also, index 2 also, we could return index 3 also, or we could return index 4 also. The normal binary search implementation that we saw previously exits as soon as it finds out any occurrence of a number in the array. So there is no guarantee that we will find the first occurrence or the last occurrence. Now in this lesson we will see 2 different variations of binary search. One variation will always give us the first occurrence of a number in the array, and another variation will always give us the last occurrence of the number that we are searching for in the array. Okay, so let us first write the basic implementation that we had written previously. I'll quickly write a method binary search that takes 3 arguments: array A, its size n, and the element to be searched for x, and we will initialize 2 variables, low and high, to 0 and n minus 1 to mark the segment of the array in which x is probable to lie. And while low is less than or equal to high, we calculate the middle index as low plus high upon 2, and then we compare x with the middle element, and if x is equal to the middle element, then we have found x and our search is over. We exit from the method by returning this index mid. So we are exiting as soon as we find any occurrence of x, not necessarily the first or the last occurrence, but any occurrence. If x is less than the mid element, we adjust high to mid minus 1 to say that x is now probable to lie before the mid element, and the third and default condition is when x is greater than the mid element. So in this case we adjust low to mid plus 1. And if we come out of this while loop without finding x, then we return minus 1 to say that we could not find x in the array. Okay, let us see a simulation of this for this particular example, simulation of this algorithm for this particular example. I will draw 3 columns here: low, high and mid, and let's say the number to be searched for is 10, so x is 10. Size of the array is 6, so initially low is 0. Size of the array is 7, so initially low is 0, high is 6. Now we have started to execute this while loop. We calculate mid as low plus high upon 2, so mid would be 3. Let's also draw a column a mid. Okay, this looks better. Now a3 is 10. So is x equal to a mid? Yes, it is. So we return 3. And we will say that game over, because we have found 10 in the array, and we return immediately. We do not care that there is another 10 at index 2. Now if we wanted to find out the first occurrence of 10 in the array, we should not have said game over. We should have said that, okay, I have found one 10 at index 3. Let me go and see towards the left if there is another 10 at any lower index, and if it is there, I will return that one. So I will modify this algorithm slightly here. At the beginning, let's say we take a variable result and initialize it to minus 1. I'll come back to why I'm initializing it to minus 1, and I'm short of space here, so I'm writing 2 statements in the same line with a comma. Now when the condition is that x is equal to the middle element, instead of returning and exiting the execution of the function, we modify result to mid, the index at which x lies, and we adjust high to mid minus 1. Once again, I'm short of space here, so I'm writing 2 statements in the same line. So these 2 statements will execute for this condition if x is equal to the middle element. Now what do I really mean here? What I mean is that if we found x in the array, then we have stored the index in the variable result at which we found x, and then we modify our segment. We do not stop our search, and we modify our search space by adjusting high to mid minus 1. So we keep on searching for x before this mid element. So if we see the simulation now, then we do not stop here. We make high as 2 and continue our search. Now mid would be 1, a mid would be 4. I will also write the value of result at any stage. So far our result is, so far we have found 10 at index 3. So our result is 3. Now for this case, low 0, high 2 and mid 1, we will go to the condition, this one, when x is greater than the middle element. So low becomes mid plus 1. So low becomes 2, high is already 2. Now mid would also be 2. A mid would be 10. Now we come to this condition. We again came to x equal to the middle element of the segment. So we now modify result to the new index at which we have found x. So result will be now 2, and high becomes mid minus 1, which will be 1. Low is 2. Now this condition low less than or equal to high fails. So we exit while loop here. Okay, there should be one more modification to my code. I will return result here. Okay, so we are saying here that found 10 at index 2. So this way we have found the first occurrence of the element 10 in the array. We are returning result here once we complete the while loop, and we are not returning result inside the loop. Result is initially minus 1, so if we do not find any x, it is never modified, and we return minus 1 to say that we could not find x in the array. And if we find any x in the array, and I'll put braces here to mark that these two statements execute for this if condition, we stored that index in this variable, kind of saying that so far this is the leftmost result that I have, and then we go on searching towards the left. By left I mean towards the lower indexes. So we modify high to mid minus 1. If we find another x, then this x is left of the previous index, so we discard the previous result and modify our result. Okay, so this is binary search to find out the occurrence of first element in the array. If we want to find out the last occurrence in the array, then there will be only a slight modification to this code. When we find x, we do not stop the search like we are doing here, and we go on searching towards the right, towards the higher indices, by modifying our window or the segment or the search space by adjusting low to mid plus 1, by adjusting lower index to mid plus 1. And this is the only change that we need to do to find out last occurrence in the array. Okay, so let us quickly see simulation for this implementation also. So once again we start with low 0, high 6, and we also start with result minus 1. Minus 1 means that we have not found x in the array so far. Now mid would be 3 and the mid element would be 10. We are executing the while loop here. Now we come to this condition, x is equal to a mid. So first we modify our result. We found an x at index 3, and then we modify low to mid plus 1, which will be 4. So earlier our window was the whole array. Now our window or search space is this, and we already have information about the rightmost 10 that has occurred so far. Okay, so now mid would be 5, a mid would be 18. Now we go to this condition, x is less than a mid. So now high becomes mid minus 1. So we have this range. Our window, our search space is now this, and so far we have found 110 at index 3. Now mid would be 5 plus 4 upon 2, and if we take only integral part, then it is 4. A mid would be 10. So once again we come to the condition when x is equal to a mid. So we modify result to the new index 4, and we modify low to mid plus 1. So low becomes 5, high becomes 5. So far the highest index of 10 that we have found is 4, and our search window is now only index 5. So mid would also be 5 and a mid would be 18. Now 18 is greater than 10, so we will once again go to this particular condition. So low is still 5 and high becomes 4 now. Now this is not a valid search space, this is not a valid segment. Low less than or equal to high condition fails, so we will exit the loop, exit the while loop, and our game is over. We return whatever we have in the result. So we will kind of say that found 10 at index 4. So This is binary search to find out the last occurrence of an element in the array, in a sorted array. The time complexity of this algorithm is big O of log n, or in other words we can say that the time taken is kind of proportional to log of n. In the coming lessons we will see more variations of binary search. We will see other scenarios in which binary search is applied. So thanks for watching.